Welcome back to part 3 of Module 5, Lesson 7, Equivalent Algebraic Expressions. We're going to start off our new session with combining like terms. And the definition says an expression is in simplest form if it has no like terms and no parentheses. You will, of course, be seeing that definition on your vocabulary quiz coming up. You can use the structure of an algebraic expression to combine like terms and write in simplest form. When you have an expression with only constants, such as 5 plus 2, you can combine these terms as a result of 7. And you can see that going on here, 5 plus 2. Sometimes you have expressions with like terms, such as 3x and 5x. Let's go ahead and highlight those right there, which means you have 3 groups of x plus 5 groups of x, like you see right here, and 3 groups of x plus 5 groups of x. Those add together to be 8 groups of x, or 8x. That is an example of combining like terms. Algebra tiles can also be used to model and simplify an expression that contains like terms. So we're going to watch their video here and see what they have to say about using
algebra tiles to simplify expressions. Simplify the expression 2x plus 4 plus 3x. To model the expression, place 2 x tiles, 4 1 tiles, and 3 more x tiles on the mat. Combine like tiles. Place the x tiles together. There are 5 x tiles and 4 1 tiles. The expression is 5x plus 4. Let's try another example. Simplify the expression x plus 5x plus x. To model the expression, first place an x tile on the mat. Next place 5 x tiles on the mat. And then place 1 more x tile on the mat. Combine like tiles. There are 7 x tiles. Simplified, the expression is 7x. Now, simplify the expression 1 plus x plus 4 plus 3x. To model the expression, place a 1 tile, an x tile, 4 more 1 tiles, and then 3 more x tiles on the mat. Combine like tiles. Place the x tiles together and the 1 tiles together. There are 4 x tiles and 5 1 tiles. Simplified, the expression is 4x plus 5.
That does a pretty good job of explaining how you combine the like terms. And you need to understand, when you're looking at like terms, they have to have the same variable with the same exponent. So x and x, 1x and 3x, have the same variable with the same exponent. 1 and 4, while they don't have variables necessarily, those are constants, so they are a like term as well. All constants are always considered to be like terms. Well, that last video misaligned a little bit, didn't it? Let's keep going here. You can use a distributive property to combine like terms. This method allows you to simplify by adding or subtracting coefficients of the terms. Remember, the coefficient is the number that comes in front of the variable. So here you have 3x plus 5x, and they use a distributive property by factoring out the x right here. And from there, they had 3 plus 5, that's going to be 8, and 8 times x, that's going to be 8x. To me, that's a little bit overkill, but if that's what they want you to do, then that's what they're going to do. How can you use a distributive property to combine terms of expressions like this? Well, you're going to group these two numbers, the x squareds, those are like terms, and you're going to group the 3x's together because the 3x's are like terms as well, and then factor out the parts that are appropriate for each one of those. Let's keep moving. So example 4 wants us to simplify 2x plus 5 plus 4x minus 2. And the question is, why are the like terms in this expression, or what are the like terms in this expression, and what property allows you to reorder them? Well, your like terms, you're going to have 2x, we're going to make that a yellow, and 4x, we're going to make yellow as well, because those are a like term. And then your constants of 5, we're going to make a blue, and 2 we're going to make blue, the constants are like terms as well. So from there, I can, in what property allows us to reorder them, that's going to be the commutative property of addition that allows us to rearrange the way they're written. So let's dive into this one. They've got the 2x plus 5 plus 4x minus 2. They're going to use the commutative property, which I really wish they went down, because you see how confusing that got when it just went boom right on the end of it? Always come underneath when you're doing your supporting work, because if it looks confusing to you here, it looks confusing to me when I'm grading it in your homework. But you can see they've done the 2x and the 4x together. That's one like term. And they did the 5 and the 2 together. That's another like term. 2x plus 4x. Are they going to factor it? They sure did. They factored out the x, giving you x times the sum of 2 and 4. The sum of 2 and 4 is, of course, going to be 6, and then 6 times x, that gave the 6x. I honestly would not do that step. I'd say 2x plus 4x is 6x, but if that's what they want, that's what they get. Meanwhile, on our constants, we have 5 minus 2. 5 minus 2 is going to equal to 3. So our answer is going to be 6x plus 3, which you can take and put a 6 here and a 3 there, and it'll give you a happy sound on your computer. Now it's going to be your turn. Work through this problem and give us a good answer. Now when I work it, the first thing I'm going to do is use my commutative property. Of course, we're going to write the first problem, which we're going to assume it's written here. Then we're going to use a commutative property and regroup our like terms. So I have a 2x plus a 6x are a like term. That is a positive 8, so it's now going to be plus 8 and minus 4, making the constants a like term as well. Factor out the x and the 2 here. And when you do that, which you don't really need to factor out the 2, so let's just factor out the x just to keep them happy. That's going to give me a 2 plus 6. And then, of course, plus 8 minus 2. 2 plus 6 is going to equal to 8. So you have x times 8 plus 8 minus 2. That gives you 8x. And I'm going to go ahead and do my 8 minus 2 here is going to be 6. 8x plus 6 is going to be the final answer. So we're going to come back over here, put in our 8x plus our 6, check our answer, and how did I get, that's not a 6, that's a 4, dummy. 8x plus 4, was I talking and not doing math again? Let's see here, I sure was talking and not doing math again. I magically changed that 4 to a 2, and that's what got me off on that problem. But what happens if you start throwing in things like exponents into it? That's okay, because ones with the same x variable and same exponents, those are like terms. So in this case here, the 5x squared and the x squared are going to be a like term, and you're going to see that when they start working the problem here. So what are our like terms? First, we're going to take our x squareds. Those are going to be right there. 5x plus, that's going to be 1x squared. And then your just x terms, it's only 1. And your constants, you have a plus 2 and a plus 6. What does it mean? Oh, my 6 didn't stick. There, it sucked. So that part's good. Let's keep going now. We're going to simplify that expression, and the first thing we're going to do is use your commutative property of addition to reorder them so that the like terms are together. You've got your 5x squared plus your 1x squared right here. 2x, he's a lonely little critter, he doesn't have any friends. And then your 6 plus 2, that's going to be your constants, which are also like terms. From here, they're going to take and, well, now they're just making magic leaps. 5x plus 1x is 6, or 5x squared plus 1x squared is 6x squared. That's what I would have done anyhow. The 2x came down, he didn't have any friends to worry about. The 6 plus 2 gave them 8, so the final answer was 6x squared plus 2x plus 8. Check your answer, and the answer checks. Easy math, nothing to do on these things. You just got to find the like terms, stick them together, add or subtract them. Now it's going to be your turn. This one looks a little bit scary because it has some fractions in it, but I trust you can handle it. Go ahead and stop the video, work on this problem. Alright, so I've written or really copied and pasted my original problem. Now I'm going to start pointing out like terms. First off, I've got my x squareds right here. Actually, I want to include that plus sign in that. So I'm going to put those together. So I have x squared plus 2/3 x squared. From here, I can pull out my x's, which I've got a plus 2x and a plus x right there, plus 2x and plus x, and then I'm going to pull out my constant, and my constant is going to be plus 2/3. From here we get to start combining like terms. Now remember, you have an invisible 1 there, so 1x squared plus 2/3 x squared, that's just going to be 1 2/3 x squared. Next on my blue, 2x plus an invisible 1 right there is going to give me 3x's. And then finally the plus 2/3, well, that's just sitting there all by itself. Jump back over to our answer key. So we're going to end up having 1 2/3 right here. This one here was just a 3, so we're going to put in a 3 there. And then this one here, it was just a 2/3, so we're going to take and put in a 2/3 and check it. The answer checks. Easy math, nothing to do in it, just take your time, combine the things that are like. Now we're going to take this a little bit further. Let me get my camera thing out of the way, and we're going to apply these same properties to write equivalent expressions. And they've shown where they have taken this expression right here and they simplified it out using the distributive property, and that gave them this, because 3 times 4x was 12x, 3 times 1 was 3, everything else at 2x squared plus x stayed the same. From there, they use the commutative properties to put it in what we call standard form. Your variable, your exponents for the highest variable comes first, and then down the line, the variable with the highest exponent comes first, and then the next highest, and so on, and then the constants always come at the end. So now we have 2x squared plus 12x plus 1x plus 3. Combine those at 12x plus 1x is going to give you 13x. So as an equivalent fraction or equivalent expression, you could rewrite what they gave us in this one and turn it into this one right here. There are two different mathematical expressions that mean the same exact thing. What property allows you to combine the like terms? Well, I just really don't know what they're talking about there. I think they're referring to the commutative property, which allows us to move them around so that we can combine them. Now it's going to be your turn. This is the last problem we're working, I think, because I'm pretty sure the next one, nope, hold on, I'm wrong. We got the 2 slide sets left to look at here at least. So we're going to take a look at this one together. Once again, we want to find an equivalent property or expression, which basically means we want to simplify this thing as much as we can. They're going to start off by using the distributive property. The distributive property means they're going to take and distribute that 1/2, whenever it gets loaded here, that 1/2 is going to distribute through this grouping symbol. 1/2 times 2x squared, that is going to equal that 1x squared, because 1/2 times 2 is 1. And x squared, that's the same thing as 1x squared. 1/2 times 1/2, that became your 1/4 right here. Everything else at 2/5 x squared stayed the same. It's right there. The plus 7, it's right there. Next, they're going to use your commutative property to rearrange the order of the problem so that the x squareds are together. So you have 1x plus 1x squared plus 2/5 x squared, and then your constants are together right here. Then we're going to take and combine the 1x and the 2/5 x squared. We're going to combine the 1/4 and the 7 so that you get the final answer of 1 2/5 x squared plus 7 1/4. And therefore, yep, it's going to be equivalent to this thing right here. I'm not going to waste the time and type all that in there. Looks like we're going to be able to squeeze this into 3 videos. It's been a long lesson, so I'm not going to do the apply problem because I think y'all are barely hanging on at this point. I do want you to work this one on your own, and then we'll come back and see what I get. Did you get a good answer? Let's see how I'm going to do mine. First thing I'm going to do is I'm going to start off by using my distributive property where I need to. That means the 1/2 stays the same, plus 1/3 times 6. Well, 1/3 of 6 is going to be 2 and of course the x is going to come down with that. And of course what I did there is just simplify and multiply. 2 over 1 was 2, plus 1/3 of 3. Once again, simplify and multiply, and that's going to give me a 1 right there, plus the 5x is going to come down, plus the 7 1/2 are going to come down. Next, I'm going to use my commutative property to combine my like terms, so everything that has an x is going to go in the front. 2x is right here, and whoops, I want to include that plus sign there, plus the 5x is right there. And from there, I'm going to take and say my constants are going to be 1/2 plus 1/2 plus 1 plus 7 1/2. From there, we can take and say 2x plus 5x, that's 7x, plus, well, the 1/2 plus the 7/2 is 8, plus 1 is going to be 9, so 7x plus 9, that should be my final answer. Come over here, let's type it in, 7x plus 9, accept, and check. The answer checks. We've done an awful lot on this lesson. This is a pretty tough stuff, guys. Take your time with it. Don't get stressed out on it. Give me a good effort so I can give you good credit for it in your homework assignment.